Have you ever wondered how AI recognizes faces or drives cars or even predicts what you'll buy next? The secret is neural networks. So, what exactly are they? Now, let's start with the human brain. The human brain, or the brain of any mammal, consists of neurons. Now, these neurons are interconnected and they are responsible for sending information from one point to the other. Everything we see or think or do, even feel, is all because of the neurons that we have in the human brain. Now, AI was designed to mimic this human brain, and so we have artificial neurons. What they do is literally take in information, which can be data or anything we feed them, process it through their layers, and then provide an output. Now, imagine you're teaching a child how to recognize a cat. So you start off by showing them cats or images of cats and say, that is a cat. And then along the line, they might actually misidentify or misclassify an animal, call a cat a mouse or something even worse. But then they kind of learn as they see more cats or interact with more cats, and then they just automatically can tell that, oh, this is a cat the next time they see one. Neural networks, they can do the same thing. They have the ability to learn and adapt at increasingly fast rates, which is so amazing. They can problem solve and literally perform loads of tasks. How does a neural network work? So let's talk about the architecture for a bit, just a brief overview. A neural network has three main components. We've got an input layer, we have hidden layers, and we have an output layer. In the input layer, raw data is received, like for instance, whatever we want to train it on. So cat images or pixels from a cat image are fed through the input layer. Now, in the hidden layers, this is where the magic happens. With all of those interconnected neurons, information is passed from one neuron to the other, and then the AI begins to identify patterns, edges, shapes, all of what makes up a particular image, for instance. And once it's able to make sense of it, form a relationship or whatever, it then passes that to the output layer. Now, the output layer is where we get a response, and then the AI predicts and says, oh, my best guess is this is a cat, and this is how sure I am. So that is just an overview of how the internal structure of a neural network works. You can feed any kind of data, text, image, video, anything literally, and then the same process happens with the hidden layers and then an output with a prediction and certainty to which that prediction was made. Another example, which is quite a common one, is an AI trying to identify handwritten numbers. So you pass the number 5, let's assume, to as an input, different variations of the number 5, and then feed all of those images into your input layer. This is then passed to the hidden layers, and then just like before, the AI starts to make sense of this, identify shapes and patterns and just all of that, and is able to know, okay, this is the number 5. So when it produces an output, it says this is the number 5, and then if you just randomly feed it another number 5 that was handwritten and the AI has not seen that example before, it will be able to predict that with some sort of accuracy. Some real-world examples that currently exist, which you may have seen or even used, would be your personalized recommendation systems like Netflix and YouTube. So analyzing all of your data, your behaviors, they are able to predict movies or videos they think you might enjoy watching. We also have self-driving cars. They can detect obstacles, they can navigate traffic, literally get you from one point to the other safely. I have never used one, but if you have, please let me know how those actually go, because I will be scared for my life. You also have AI powered medical diagnosis. These days, AI is increasingly used in health and fitness. You've got MRIs or X-rays, just medical images in general, being scanned, and then AI helps doctors make diagnoses. You may have heard that at this point in time, breast cancer can be detected up to 5 years early using advancement in computer vision, which is all AI stuff. That is also pretty cool. In sports and fitness as well, especially with like athletes or big teams, when their data is collected, they're able to predict potential injury risks, even provide personalized training for athletes to optimize their performance, which is my area of research, and a lot more other stuff. So think of anything, I believe it's all AI powered, and this is just a snippet of what these neural networks are capable of. Let's talk about why these are so powerful. Before now, we just had traditional programming, which is basically just writing a set of rules and updating them. So you can see that with traditional programming, there will be some flaws, but with neural networks, they are able to learn from experience, and then the more data they process, the better and smarter they become. So they're only as good as the amount of data that is being fed to them. And this hence eliminates the need for traditional programming, which can be tasking to have to write every single rule for a computer to follow. And that, my friends, is how AI thinks. Now, neural networks are the foundation of deep learning, which is what I'll be talking about next. So if you did enjoy this and are curious to learn more, stick around and I will see you next time. Thank you for watching.